Dear students, in the previous lectures, we derived some formulas using the first principle of derivative, and using those formulae, we evaluated some problems like derivatives for some functions. Sometimes these formulas obtained so far may prove to be difficult in finding the derivatives of some typical functions. So there are special methods of differentiations to deal such type of situations. So the main thing in this lecture is to discuss those methods. So they are number one, substitution method. Second one, logarithmic differentiation. Third one, parametric differentiation. And fourth one, implicit differentiation. So in this lecture, we'll discuss substitution method and logarithmic differentiations. So by using these two methods, we need to find or evaluate the derivatives of such functions. So number one, substitution method. See the method. If y is f compose g, if we are able to find a function h such that g compose h is f inverse, then here the substitution may be exist like x equal to some function in terms of u or t or some other variable. So it is like x equal to some h of u. So this may give the derivative of the given function y with respect to x easily. Here f is here the inverse is exist, means f compulsory a bijective function. Here f is a bijective function. So just you need to identify whether it is included with the substitution or not only. So no need to evaluate the inverse of the given function. So let's see an example regarding the substitution method, means how we need to substitute. So example 1, if y equals to sine inverse of 3x minus 4x cube, then find the derivative of y or dy by dx. And see the solution for this. So without using substitution also, if we can find the derivative of this function, since it is in the form of sine inverse of u. So we know the sine inverse of u derivative, and so the inner function is 3x minus 4x cube. Now, so for this problem, how to use the substitution method. Now, see, if we substitute x equals to any trigonometric function or other functions, so by substituting that type of trigonometric functions, we need to get the derivative easily. So that you need to identify the suitable substitution. See here, so it is 3 into x minus 4 into x cube is there. If we replace this x with sine theta, then what happens? 3 into sine theta minus 4 sine cube theta, right? So there is a formula, put x equals to sine theta or sine u, no problem, sine theta or sine u. Now, so what will happen? So this is y equals to sine inverse of, now so it is 3 sine theta minus 4 sine cube theta, right? Now this is sine inverse of, so we know the formula from trigonometry, 3 sine theta minus 4 sine cube theta, that defines sine 3 theta, right? So simply we can write it as sine of 3 theta. And so we know one more identity in inverse trigonometric functions, that is sine inverse of sine theta is theta, but instead of theta here 3 theta is there, so therefore this is 3 into theta. Y equals to 3 theta is there. Now, see, somewhat it is simplified, but y is always in terms of x only, since the given function is in terms of x. Now, so you need to replace theta. That is 3 into theta can be written as, see, x is sin theta, then theta is what? Sin inverse of x. So this is 3 into sin inverse of x. So y equal to 3 sin inverse of x. Now apply the derivative. So differentiate on both sides. Differentiate on both sides with respect to x. With respect to x. Now, so this is dy by dx. On left hand side it is dy by dx of y, and this is 3 into derivative of sin inverse x. Derivative of sin inverse x, that is 1 by root of 1 minus x square. So this is 1 divided by square root of 1 minus x square. So the derivative of this is 3 divided by root of 1 minus x square. By using chain rule also you can evaluate. So chain rule use chesi kuda find the but the simplification may be complicated. So better use the substitution method. అంతేగాని వేరే మెథడ్లో చేయలేమా అని కాదు. సో యూ కెన్ డూ దిస్ వితౌట్ సబ్స్టిట్యూషన్ ఆర్ విత్ సబ్స్టిట్యూషన్. సో విత్ సబ్స్టిట్యూషన్ ఈజ్ రెడ్యూస్ సమ్ ఈజీ వే. Now second one, y equals to tan inverse of square root of 1 minus x divided by 1 plus x. Now, so here what we have to replace with the x. So is there any related formula in trigonometry? So to simplify this into tan inverse of some like a tan theta model. So if you replace x with the cos theta, then it is 1 minus cos theta and it will be 1 plus cos theta. So there is a formula in trigonometry. It is 1 minus cos theta is 2 sin square theta and theta by 2, and 1 plus cos theta is 2 cos square theta by 2. So put x equals to cos theta. Then the given function that becomes y equals to tan inverse of square root of 1 minus cos theta divided by 1 plus cos theta. So we are familiar with these two formulae in trigonometry. So this is a tan inverse of square root of 1 minus cos theta is 2 sin square theta by 2 divided by 2 into cos square theta by 2. Right? Here 2 and 2 will be gets cancelled. Now, so this is of tan inverse of, not tan inverse into. So it is tan inverse of this. So finally it is tan inverse of, so this is square root of tan square theta, sin square theta by tan square theta by 2. So it is tan square theta by 2. Now, so finally we can write it as the tan inverse of tan theta by 2. Now it is the tan inverse of tan theta model. So tan inverse of tan theta is theta, but instead of theta, theta by 2 is there. So the value of y is theta by 2. Now, so y in terms of x you can express. So it is 1 by 2 into theta can be written as cos inverse of x, since x is cos theta. X equal to cos theta means theta equal to cos inverse of x by inverse trigonometric functions. Now apply the derivative. Now, so we will get easily the derivative of this function. So 1 by 2 into derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. So finally this is minus 1 divided by 2 into root of 1 minus x square. So this is the derivative of y equals to tan inverse of 1 minus root of 1 minus x by 1 plus x. Now third one, y equals to tan inverse of square root of 1 plus x square minus 1 divided by x. So here what we need to substitute here, m substitute చేయాలి మనం అనేది so it depends upon the practicing the problems. Okay, now so if we substitute x equals to cos theta, then what happen? 1 plus cos square theta. So we cannot simplify, means we need to cancel out this square root. So here 1 plus cos square or 1 plus sin square, so we cannot return it in the form of single trigonometric ratio, right? If x is tan theta, then 1 plus tan square theta is there. 1 plus tan square theta can be written as secant square theta. So at that time, so we may cancel that square root, right? Now so put x equals to tan theta, put x equals to tan theta, then so the given function y which becomes tan inverse of square root of 1 plus tan square theta minus 1 divided by tan theta. Now so this is the tan inverse of 1 plus tan square theta, which is secant square theta, right? Secant square theta minus 1 divided by tan theta. Now so tan inverse of secant square theta means it is secant theta, secant theta minus 1 divided by tan theta. Now say the tan inverse of secant theta, so that can be written as 1 by cos theta. Now 1 by cos theta minus 1 whole divided by sin theta by cos theta, since tan can be written as expressed as sin by cos. So this is a tan inverse of now 1 minus cos theta divided by cos theta whole divided by sin theta by cos theta untunnadu. So cos theta cancel అయిపోతుంది. This is 1 minus cos theta by cos theta whole divided by sin theta by cos theta is there. So cos theta and that cos theta will be gets cancelled. Now so 1 minus cos theta can be written as 2 sin square theta by 2 from half angle formula. So here which is tan inverse of now it is 1 minus cos theta is nothing but 2 sin square theta by 2 whole divided by, now it is sin theta is there. Sin theta by using half angle formula, that is 2 sin theta by 2 into cos of theta by 2, right? Now this, so here 2 and 2 sin theta gets cancelled. This 2 and 1 sin theta and this sin theta will be cancelled. Now finally we can write it as tan inverse of sin theta by cos theta is left, so it is tan of theta by 2. Now tan inverse of tan theta, it is theta only, means it is theta by 2. Now it is 1 by 2 into, now theta can be written as tan inverse of x, since ఎందుకు మనం x ఈక్వల్ tan theta అనుకున్నాం, theta ఏమవుతుంది tan inverse of x. So replace the theta with tan inverse x. Don't derive directly, since with respect to expression of theta మనకి unknown. So we need to replace this theta in terms of x. So now differentiate dy by dx, which is equals to 1 by 2 into tan inverse of x. d by dx of tan inverse of x is 1 divided by 1 plus x square. That means 1 divided by 2 into 1 plus x square. So derivative of tan inverse x is 1 by 1 plus x square. So finally the derivative of this function is 1 by 2 into 1 plus x square. Okay, so substitute చేయడం వల్ల మనకు ఆన్సర్ సింపుల్గా వచ్చేసింది. So otherwise it may be difficult to evaluate the derivative of this, or simplification may be difficult. So then fourth one, y equals to tan inverse of a minus x by 1 plus a into x. So here x is a variable and a is some constant, right? A is a constant. So here we can replace x with some tan theta. So this is like a minus b by 1 plus a into b form, right? So that you need to replace this constant with a constant trigonometric ratio, like a equals to, put a equals to some tan of a తీసుకుంటున్నాను, tan of a, and a angle and fix అయిపోతుంది. So if you substitute this angle a particularly, then so you may get some number a. So and x equals to, so this is unknown thing, tan theta, x variable got theta also variable. Now so y equals to, this is a tan inverse of, now so what will happen, a is a tan a minus tan theta divided by 1 plus tan a into tan theta, right? Now అది ఎలా కనిపిస్తుంది మనకి? సో దిస్ ఈస్ ద ఫార్మ్ ఆఫ్ tan a minus tan b by 1 plus tan a into tan b. It is tan inverse of a minus b. Tan inverse of a minus b means a minus theta. And again ఇక్కడ మళ్ళీ ఒక ప్రాపర్టీ యూజ్ చేస్తున్నాను. సో tan inverse of tan theta, but theta ప్లేస్లో ఉంది a minus theta, so which is equals to a minus theta, right? Now so y equals to, a is constant, so we can write it as a tan inverse of a also, no problem, again it is a constant, right? Now minus theta is nothing but tan inverse of x. Okay, now apply the derivative here. So d by dx of y is equals to derivative of tan inverse of a with respect to x is 0, since it is a constant. A already fix అయిపోయింది కదా, so tan inverse of a minus derivative of tan inverse x is 1 by 1 plus x square. So finally it is minus 1 by 1 plus x square. So the derivative of this is minus 1 by 1 plus x square. So the next method is logarithmic differentiation. So there is a great use of logarithms in finding the derivatives of some functions. They are in the form of f of x power g of x, f of x power g of x, or f of x to the power of f of x, or g of x power g of x, or the polynomials in the form of a product, like x into x plus 1 into x plus 3 divided by x plus 4 into something. So that so you need to apply the differentiation on both sides, then apply derivative. So y equal to f of x to the power of g of x form. So better to use the logarithms, then apply the differentiation. If we apply the logarithm on both sides, therefore it is log of y equals to logarithm of f of x to the power of g of x. So by power rule we can express it as g of x into log of f of x form. Okay, so we'll see the method of logarithmic differentiation using an example. X to the power of x, where x is a positive number, means x greater than 0, then find the derivative of this function, dy by dx or d by dx of y or y prime. Now see the solution. Here this is in the form of f of x power g of x, both f and g are same here. Now in this case we need to use the logarithms. Now so taking logarithm on both sides, so that it is a log y which is equals to logarithm of x to the power of x, right? Now so this is a logarithm of y which is equals to, by power rule, see log of x to the power of n can be written as n into log x, right? So similarly we can write it as x into logarithm of x. Now so differentiate on both sides with respect to x, then what happened? So this is the logarithm of y, logarithm of y means 1 by y into, so y is the inner function of x kada. So y is a function of x, so that you need to apply the derivative for y also. So this is a dy by dx. If it is log x, then simply we can apply 1 by x, right? But here y is there, y is a function of x, so then 1 by y into derivative of y again. Now here, so u into v, right? So x into d by dx of log x plus log x into derivative of x. Now, so this is 1 by y into dy by dx, which is x into, now log x derivative is 1 by x plus log x into derivative of x is 1. Now finally it is dy by dx is equals to, now so this is y times of, here x and x gets cancelled, so that it is 1 plus log x. Now so this implies dy by dx is equals to y means x to the power of x power x times of 1 plus log x, 1 plus log x. So the derivative of x to the power of x is x power x into 1 plus log x. So don't apply x to the power of n formula or n to the power of x. So already we have two formulae, right? X to the power of n and n to the power of x. X power n, x is variable and n is a number. Here n to the power of x means n is a number or a constant, x is a variable. So whereas in this problem x power x is there. Okay, so here so we can create 4 cases, right? X to the power of n, n to the power of x, n to the power of n, and x to the power of x. So we know the formula for this. Here the base is variable, power is constant, then it is n into x to the power of n minus 1. So n to the power of x, here the base is constant and the power is variable, therefore it is a logarithmic, n to the power of x into log of n. Now here n to the power of n, so both base and power are, both the powers power and base are constant, so therefore the derivative of that constant is always 0, and x to the power of x is both x and power and base are variable, so that we need to apply the derivative for this. So don't apply power rule or a power x formula for this. Do not. So next, y equal to sin x to the power of x, sin x power x. So taking logarithm on both sides, therefore it is log y is equals to logarithm of sin x power x. Here it is in the form of f power g, right? Now so log y is equals to, now so we can write it as x into logarithm of sin x. Now so differentiate on both sides with respect to x, differentiate on both sides with respect to x. Now so logarithm of y is 1 by y into dy by dx, which is equals to, now x into derivative of log of sin x, means it is u into v form, log of sin x, plus log of sin x into d by dx of x. Now so which is x into derivative of log x form, so it is 1 by sin x, 1 by sin x into derivative of sin x good normally. It is a chain rule, right? Log of x form only, so 1 by x. If it is x, then directly it is 1, but instead of x, sin x is there, so that you need to apply the derivative for that inner function. Now it is a log of sin x into derivative of x is 1. So finally this is 1 by y into dy by dx, which is x into, now so x by sin x into, now derivative of sin x is cos x, plus log of sin x, log of sin x. Now so dy by dx is equals to what? Then this is a cross multiplication, so it is y times of, now x into cos by sin, that is cot x, plus log of sin x. Now so finally, so what is y? Y means sin x power x, so this is a sin x to the power of x into x cot x plus log of sin x. So this is our derivative of this function. So derivative of sin x power x is this one. So we can evaluate the derivative of x to the power of sin x also, or sin x power sin x, or sin x power cos x, or sin x power tan x, or reverse tan x power cos x also. So we'll see some more problems. If you know, so it is in the form of f of x power g of x, then apply the logarithm, taking logarithm on both sides and differentiate. So we'll get like this. So y equals to log x to the power of tan x. So log x power tan x is there, even though it is in the form of f power g. So apply the logarithm on both sides. The f and g plus y function variable type lo unte compulsory logarithm apply chesesanu. So log y, which is equals to logarithm of, which is log x to the power of tan x. Now, so this is logarithm of y, which is equals to, now it is in the form of log of x to the power of n form. So therefore n into log x form, right? So that it is a tan x, tan x into, this is a log of log x, log x. Now, so differentiate on both sides with respect to x. So this is 1 by y into dy by dx, which is tan x into derivative of, this is, so dy dx of logarithm of log x plus v into u dash. So it is a log of log x into d by dx of tan x, Now, so 1 by y into dy by dx, this is the tan x into derivative of, this is log x, right? So that it is 1 by log x వస్తుంది, x plus ఏది ఇక్కడ వచ్చేసింది. సో 1 by log x into derivative of log x, మళ్ళీ into derivative of log x. Now plus log of log x into derivative of tan x is secant square x. Now, so this is dy by dx equals to y times of tan x by log x into 1 by x plus secant square x into log of log x. So finally, say replace with the given value y. So y means it is log x to the power of tan x into, so this is a tan x by x into log x plus secant square x into log of log x. So this is the derivative of the given function, that is y equals to log x to the power of tan x. Now say the fourth problem, y equals to x to the power of tan inverse of x. Again it is in the form of f power g. So better apply the logarithm on both sides. So this is log y, which is equals to, now this is a logarithm of x to the power of tan inverse of x. Now again it is a power rule, right? So that we can write it as a tan inverse of x into log x. Now differentiate on both sides with respect to x, so that it is 1 by y into dy by dx. This is tan inverse of x into d by dx of log x plus log x into d by dx of tan inverse of x. Now, so this is tan inverse of x into 1 by x, derivative of log x is 1 by x, plus log x is into tan inverse of x derivative is 1 by 1 plus x square. So this is actually 1 by y into dy by dx, right? So dy by dx is equals to, now in that cross multiplication y avutunda, so y is y times of tan inverse of x by x plus log x by 1 plus x square. Now so what is y? Just replace y with the given function x to the power of tan inverse, sorry, so it is tan inverse of x into tan inverse of x by x plus logarithm of x divided by 1 plus x square dy by dx. This is tan, or here I am writing again x to the power of tan inverse of x So dear student, I hope you understand these two methods.